Hello everyone. Let me give a brief introduction to our project. This project focuses on predicting the online gaming behavior using machine learning. So, with the rapid growth of online gaming, understanding how players interact with the games has become very important for gaming developers and companies. Players behave differently depending on their preferences, playing habits, and experience levels. So by predicting player engagement level, we can improve game design, enhance player satisfaction, and support business decisions. One of the main challenges in gaming is player retention. Not all players stay active for long, and some lose interest quickly. For this project, we used a dataset from a Kaggle. Let me show you. For this project, we use this dataset from the Kaggle, and here it is. It contains information about players, including demographics, likes, age, and gender, gameplay characteristics like game genre and difficulty level, and activity metrics like playtime, number of sessions, and achievement unlocked. So the target variable is engagement level, which is categorized as high, medium, or low. Before training the machine learning models, we perform data preprocessing. Here it is. This involves several steps. Removed unnecessary data and handled missing values. Converted categorical data into numbers and scaled numerical values. Created new features and removed outliers. Split the dataset into training and testing sets and balance the data using smooth. So after pre-processing, the dataset is ready for machine learning. In this project, we used four supervised ML models, logistic regression, support vector machine, decision tree, and a random forest. So let's start with the implementation of logistic regression and its performance.
Hello everyone. Today I will be presenting my section related to logistic regression. In this model, first we started this model training by importing the required libraries. Next we loaded and preprocessed the data. Next we split the data into training and testing data set according to 80-20 rule. Here you can identify that where the engagement levels across the three levels, medium, low, and high. Here, next we train the baseline model. So then we evaluated the baseline model. Here you can identify that in the high engagement level, we can identify that they have a 0.89 of recall and F1 score 0.87 and precision of 0.86. So this means the model is very effective at predicting higher level predictions. In the lower level, we can identify that 0.87 of recall and 0.72 of precision. So it is somewhat lower than the higher level. So it is quite uh, different from the higher level. So we can identify in the next one the medium, which has precision 0.90, which they predict positive cases more highly than high and low levels. So overall, we can identify that all the models perform well with strong accuracy and balanced classification. So this is the conversion matrix we derived. So here, 1,833 cases of lower level are correctly identified as lower level, while 1,797 of medium level are correctly classified as medium level, while 3,035 in higher level are classified as higher level. So there are some issues here because here 94 of lower level cases are identified as medium level, and here 66 of medium level are classified as lower level. So there are some deviations in the model that we have to address. So here next we identify the feature importance coefficients. So here we can identify the most important features. So here you have to identify Total weekly playtime is the most important feature. So next we did the hyperparameter tuning. So here we did search CV to find the base parameter for the model. So it is tested using multiple combination using cross validation and while using C-believe as the 10 as 10. So we use C-believe as 10 because higher C-believe reduces regularization, allowing model to fit the data, which improve performance in this case. Uh, so here we can identify next the ROC term. So we use the one versus rest approach. Here, the ROC curve shows that a model performs well with a data set because an AUC of 0.9 take all classes, which means it can accurately distinguish between different levels. So the ROC curve helps us to understand how well the model separates classes across different thresholds, not just at one point like accuracy. So that's what I have to demonstrate with regard to logistic regression. Thank you.
Hi, I'm Ratnavira TT. I did the support vector machine part for this project. Today I will show you what the model learned and how well it works. So basically, we are trying to predict if a gamer is a highly engaged, medium engaged, or low engaged. I used SVM model for this. You can see the screen. Also, I use scalar SVM by using import linear SVC. You can see the code. Also, you can see the training data shape from in my terminal. So this is the training shape from my terminal. Uh, Classes we are predicting is high, medium, low. Also, after training and testing, here's how accurate my model is. The accuracy is 71%, which means out of 100 predictions, about 71 are correct. You can see final SVM evaluation result on the terminal. Accuracy is 0.77. Accuracy is 71%. Prediction is 73%. Recall is 71%. Fun score is 71%. Prediction is how many high predictions are actually correct. Recall is how many of the real high cases are actually catch. The F1 score is the balance between those two. Uh, I also measured something called ROC AUC. This tells us how good the model is at the ranking prediction, not just binary yes or no. ROC AUC percentage is 87.83. The pretty that's pretty good. Closer to one is better, and 0.8 means the model can be clearly distinguish between the three classes. I also checked if the gaming behaviors matter the most for the predicting engagement. The top three features are total week playtime, session per week average session duration minutes. This makes this sense, right? If some plays a lot hours per week, they are probably more engaged. This table shows one metrics. This table shows where the model gets confused. The diagram is correct prediction, the rest are mistake. Confusion metric. You can show the confusion matrix table. High engagement predict pretty well, but the mix up medium and low a lot, that's okay. It's still decent. So to summarize, my SEO model is 71% accurate, has an accuracy of 0.88 and shows that playtime is the most important factor for engagement. We also generate confusion metrics and rock curves which are slaved in the project. That's my works. Thank you.
Now I will explain my part, which is the decision tree used for predicting the player engagement level. A decision tree is a supervised machine learning algorithm used for classification. In our project, it classifies the players into three categories: high, medium, and low. The tree splits the data step by step based on the feature values. And decision trees are simple to understand and easy to visualize, but a single tree can sometimes overfeed data, which is why tuning the tree is important. So here I trained the decision tree using preprocessed dataset. The dataset already had been cleaned, encoded and scaled and balanced with smooth. We used decision tree classifier and performed grid search CV to find the best parameters like maximum depth, minimum samples, and uh, minimum samples per leaf, splitting criterion. This process helped the model to learn patterns in the data while preventing overfitting. So in here, this is the confusion matrix. So after training, I evaluated the model with this several metrics. The decision tree achieved an accuracy of 0.913, which is very strong. I also measured the precision, recall, and F1 score to understand performance score or classes. The confusion matrix shows the most predictions are correct with the highest values along the diagonal, meaning the model is classifying player accurately. So I also evaluated the model using ROC-AUC with a one versus reset approach. This helps to understand how well the model separate each classes. The ROC curves for all classes show that the model distinguishes between high, medium, and low engagement player effectively. And in here, the decision tree visualization. One useful feature of decision tree is that we can visualize the entire tree. This allows us to see how the model splits the data at each node and understand why a player is classified as high, medium, or low engagement. It makes the model interpretable and easy to learn. So we can also use this model to predict engagement for a new player. So by providing the player's data, the model calculates the predicted class and the probability for each engagement level. And this is useful for real-world application where we want to identify new players' engagement patterns immediately. So in summary, the decision tree is a simple, interpretable, and accurate model for predicting player engagement. With an accuracy of 91%, it performs very well in classifying players as high, medium, or low engagement. It also provides clear insights into how decision trees are made and can be applied to a new player data for practical predictions.
Hi everyone. Now I will explain my part, which is the random forest model used for predicting player engagement levels. A random forest is a supervised machine learning algorithm used for classification. In our project, we use it to classify players into three categories: high, medium, and low engagement. The main idea of random forest is that instead of using one decision tree, it creates many decision trees and combines their results. Each tree makes a prediction, and the final output is selected based on majority voting. Because of this, random forest reduces overfitting and gives more accurate and stable results compared to a single decision tree. Here I trained the random forest model using preprocessed dataset. The dataset already went through cleaning, encoding, scaling, and smart balancing. The model is created using random forest classifier with a fixed random state of reproducibility. During training, the model builds multiple decision trees using random sampling of data, random selection of feature at each split. This help each tree learn slightly different patterns from the data. After training, I evaluated the model using several metrics such as accuracy, precision, recall, and F1 score. The model achieved around 91 accuracy, which indicates strong performance. This confusion matrix shows how well the model predicts each class. Most values are on the diagonal, which means the model correctly classified most of the players. One important advantage of random forest is feature importance. From this graph, we can see that total weekly playtime is the most important feature. Also, session per week and average session duration minutes are highly important. This makes sense because player activity directly affect engagement level. To improve performance, I use GridSearch CV for hyperparameter tuning. I tested different values like number of trees, tree depth, and split conditions. The model automatically selected the best parameters based on cross-validation. I also evaluated the model. I also evaluated the model using ROC AUC with one versus rest approach. The ROC curve shows that the model has strong class separation ability. Higher AUC higher AUC value means better performance in distinguishing between classes. Overall, Random Forest gave the best performance among all models. It handled complex patterns well and provide accurate and reliable predictions. Thank you. Hi everyone. Now I will explain the results and discussion part of our project. In this session, we evaluate and compare the performance of four machine learning models: logistic regression, support vector machine, decision tree, and random forest. We use several evaluation metrics such as accuracy, precision, recall, F1 score, and ROC AUC to measure how well each model performs. First, let me show the overall results table. From this table, we can clearly see the performance differences between the models. Logistic regression gave a good start in results. Accuracy is around 83%. Other values like precision, recall, and F1 score are also balanced. This means the model performs fairly well overall. But since it is a linear model, it cannot capture more complex patterns in the data. Next, the SVM model shows the lowest performance. Accuracy is around 71%. F1 score is also lower compared to other models. This means SVM struggle to understand the patterns in this dataset. Even though SVM is powerful in our case, it didn't perform well, possibly due to a dataset complexity. Decision tree performed much better. Accuracy is around 91%. All other metrics are also high. This shows that decision tree can handle nonlinear relationships well, but one issue is it can sometimes overfit the data. Finally, Random Forest gave the best performance. Highest accuracy around 91.5%. Very strong precision, recall, and F1 score. Highest ROC AUC value. This is because Random Forest combines multiple decision trees, which helps to reduce errors and improve stability. Now let's look at the graph. This graph shows that Random Forest and decision tree perform the best. Here also we can see similar behavior. Random forest has the highest value, which means it separates classes very well. This gives a clear summary of all models. Finally, based on all results, Random Forest is the best model. Decision tree is also strong but slightly less stable. Logistic regression gives a good baseline. SVM performs the worst in this case. So overall, Random Forest is the most suitable model for predicting online gaming behavior. Thank you.